All right, graphing the sine function. Last year you may have done like a worksheet where you filled in all the values and then plotted them and graphed it. Do you guys remember that? Okay, so we're going to just do that on a smaller scale. We're not going to plot as many points, but we're going to plot what I call the 5 key points. Okay, so we are going to graph y equals sine of x. It could be called sine of theta as well. Okay, so this is x, this is y, and I'm going to put for y sine of x, because that's what y equals. Okay, the 5 key values we're going to use are the 5 quadrantals when you go around. So 1, 2, 3, 4, and back again. So what is the first one? 0. And as a radian, what is this one here? Pi over 2. This one here? Pi. 270 is 3 pi over 2. And back to where we started is 2 pi. Okay, so if you can remember these 5 key points, you'll master how to graph the sine function. Okay, so, bless you. I'll make that a little bigger and a little darker. Ordered pairs. Sine is the x value or the y value? The y. All right, so let's go ahead and do this. I want you to do the same thing. 0, -1. Okay, what is sine of 0? What is your y value? Thank you. 0. Pi over 2, what is your y value? 1. Pi, 0. 3 pi over 2. And back to where we started, 2 pi is 0. Okay, I have these for John, Zach, and Karina. No, I gave you the wrong one. I can hand it to him. He's coming. Okay. You don't like it? All right, so I'm going to put 1, 2, -1, -2. This here, these are my y values, the 0, 1, 0, -1, 0. These are going to be the x values, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. You try to get them out as even as you can. What I usually do is just go to where I want to end. So say I call this 2 pi, and then I cut that in half, and I just approximate where the midpoint would be and what's half of 2 pi. Pi, and then I cut pi in half, and again I approximate what's pi cut in half. Pi over 2, 1 over 2, 2 over 2, this would be 3 pi over 2 and 2 pi. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Do you see that? So the 5 key points, 1, 2, 3, 4, don't forget 0 is one of them. 1, 2, 3, 4, 5. All right, let's plot. 0, 0 is 1 point. Pi over 2 is 1. Pi is 0. 3 pi over 2 is -1. And 2 pi is 0. Okay. So, do you guys remember how you connect these? You don't make V shapes, they're not straight lines, they're curves. When you did this last year, you did a bunch of dots in between. The more points you pick in between here, like if you did 30, 45, 60, and all the angles in between, you would see that there's a bunch more dots in here, and it looks curvy like this. So think of a hill and then a valley, and it all connects nice and smooth. And that there is your sine graph over one period. One period is around the circle once, from 0 to 2 pi. That's one period. Now, do sines go on forever? If I were, could I keep graphing this? Yes, more periods, it would continue. The next period would end at 4 pi, so I would just continue to the right. I could even continue to the left, and sines just oscillate between 1 and -1 forever. Now, just a regular sine graph, y equals sine x, is it ever going to get higher than 1? No. Is it ever going to get lower than -1? No. Does that make sense? Now, there are things that we can change to the sine graph to make it go higher or lower. Does anybody remember from last year what we call this? The what? Good job, the amplitude. The amplitude is 1. We'll write that down in just a little bit, but the amplitude is 1. Okay, questions here before we try the next one. Okay, and I'm going to do the next one on the same graph. We're going to graph, I put this one in blue, I'm going to use different colors. We're going to graph y equals 2 sine x. Okay, anybody remember what the 2 does to the graph? It makes it go higher, so it changes the what? The amplitude. Okay, so not only does it make it go higher, but this here will also go lower. Okay, so I'll do this one in purple. Let's first make our t-chart. X and 2 sine x. And we're going to use the same key points that we did over here. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, now the only difference is I'm taking my answers and multiplying it by 2. So I'm pretty much taking these answers here and multiplying them by 2. So let's see. 0 times 2 is 0. Pi over 2 is 1, or I can take the 1 from right here and multiply it by 2. What do I get? 2. Pi is -1, or I can, 0. Or I can take it from right here, the 0, and times it by 2. What do I get? 0. -1, or take it from here, times 2. What do I get? -2. And the last one, 0. Okay, so let's plot these points as well. 0, 0, 2, pi is back to 0, 3 pi over 2 is -2, and 2 pi is back to 0. So again, you have your hill and your valley, and it's nice and curvy. There's no straight lines or V shapes. Try to get it as curvy as you can. All right, bless you.
Thank you.
Okay, questions? Sienna, did you do this last year? Because you weren't here last year, right? Yeah. But you did. Okay. All right. Next one we're going to graph is y equals negative sine x. Y equals negative sine x. Now, this amplitude was 1 because the coefficient was 1, right? What's the amplitude on this one? This one is 2 because that's the highest and the lowest, yes? Any guesses? Anyone remember what the amplitude is here? It's 1. Is amplitude ever negative? No. Absolute value of your coefficient. Absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of -1 is 1. Does anybody remember what it does to your graph? Okay, so instead of going, it reverses it. Instead of going high and then low, he's saying it goes low and then high. All right. Let me find a color. Okay. So let's make our T-chart. Now this one, I'm going to take my original answers and multiply them by what? -1. Negative sign x, same x values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so let's just do them from here a little quickly. 0 times -1 is, 1 times 1 is, 0 times -1, -1 times -1, and 0 times -1. Sorry. Do you see why everything flips around? Okay, so we start off at 0, 0 again, and then pi over 2 is -1. Pi is back to 0. 3 pi over 2 is +1. And 2 pi is back to 0. So again, now you have a valley and then a hill, and it's all nice and curvy and smooth. Okay, so today we're just going to really focus on one period. We're not going to do any shifting or stretching. We will do doing stretching this way, but we're not changing too much of it. Thursday, we'll learn more of the shifts. Okay, questions before we move on? Okay, let's just quickly write it up here then. The amplitude for this one, I'm going to put AMP. The amplitude was what? 1. And the amplitude here? 2. And the amplitude here? 1. Because absolute value of -1 is 1. Okay, questions before we move on? Okay, vocabulary type of questions. You'll need to know what they're asking. Number 1, what is the highest y value for y equals sine of x? What is the highest y value for y equals sine of x? Okay, let's go back to our graph. Which one is the original sign? The blue, the purple, or the pink? This blue in here. And what is the highest value? 1. Is it the amplitude?
Yes.
Is it always going to be 1 in this blue graph?
Yes.
Is it ever going to go higher than 1?
No.
No, it's not. It's going to, what did I say earlier, oscillate. It's going to oscillate between 1 and -1 forever. All right, so what's the highest value? 1. Number 2. Oh, before I give you number 2, I do want to add a question here. So we'll call this A and B. Where does it occur? What is the highest y value for sine of x? 1. Where does that highest value occur? What are they asking you here for what? When it's saying where does it occur, are they asking for the x value or the y value? The x. So 1 is the highest. Where does it occur? Is there more than one high point for just one period? No, this is it. If I continued, there would be more high points, but in this one period graph, the highest is 1, and it happens when? Pi over 2. All right, number 2. What is the lowest y value? For y equals sine of x. Okay. Same function, y equals sine of x, the blue one here. Where what is the lowest value? Are they asking for the x or the y? The y. And what is the lowest value? -1. Now, I only have one period, but if I continued, would it ever go lower than -1? No. And again, in this period, this one period, that I only have one low point, a max and a min and 3 zeros. Okay, so what did we say it was? -1. I'm not going to write down the question, but I do want to just say it out loud. Where does it occur? 3 pi over 2. Do you see that? Okay. Number 3. Y equals sine x has a y value of 0 for what radian values? Y equals sine x has a y value of 0 for what radian value? Okay, let's go back to our graph. I just said it earlier. This blue graph here has one maximum, one minimum, and how many zeros? 3. Do you agree that this point, and this point, those 3 points, that's when the function has a y value of 0? Yes? Okay, so they asked, when does it have a y value of 0? I just called them zeros, which is another way you'll hear it. What else are these called? X intercepts. X intercepts, your roots, your zeros. So pay attention to the different ways they're going to ask for it. All right, so they're asking here for the x intercepts, and how many do we have? 3. So where do they occur? Y equals for what radian values? Is 0 one of them? Comma, look at your graph. What's the next one? Pi, comma, look at your graph. What's the last one? 2 pi. Now, if I continued that graph more than one period in both directions, would I have more zeros? Definitely. It would go on forever and ever. But over one period, 0 pi and 2 pi. Any questions? Okay, number 4. Y equals sine of x reaches its max height, and I used that word earlier, maximum and minimums. Y equals sine x reaches its max height at what radian value? So go back to your graph. When is it? The blue graph, when is this the maximum here?
Yes.
And when does it happen? At what radian value? Pi over 2. Was this question asked earlier a little differently? Yeah. Where did that question come up? Right here. What is the highest y value? Is that the same as saying max?
Yeah.
And then the question, where does it occur? At what radian value? Pi over 2, pi over 2. Make sense? All right. Next thing we're going to talk, we're actually going to put it in writing, the word that you guys brought up earlier, which was the amplitude. All right. You do need to know what amplitude is, and know that it's always the absolute value. Okay. Now I'm going to write the actual definition down. Typically when we talk about it, we don't refer to it this way, but I do want to write it down because we will use it eventually. It is half the distance between amplitude is half the distance between the maximum value and the minimum value. And what did we say? It must always be what?
Positive.
positive. I'm going to put that in parentheses here. It must always be positive. So you always take absolute value. Positive. Sorry, that got sloppy. Okay, so let's just take a quick look on the blue graph. What's the distance between the max and the min? Up 1, down 1. What's the distance between 1 and negative 1? It's 2. And then what does it say, the definition? You cut it in half. And what's 2 cut in half? 1. Okay, let's look at the purple one. The max is 2, the min is negative 2. What's the distance between 2 and negative 2? 4, and 4 cut in half is 2. The pink max is 1, min is negative 1. What's the distance between 1 and negative 1? 2, and 2 cut in half? 1. Does it matter that it's flipped around? No. It's the same thing. The distance here and here is 1. Cut in half. I'm sorry, 2. Cut in half is 1. Yes.
Is it safe to say that the amplitude is the highest part on the graph? Highest point on the graph?
Not necessarily. Right now, before we do any shifting, yes. His question was, is it safe to say the amplitude, for example, is 2? It's 1 here, and this highest point is 1. Is it safe to say it's the highest point on the graph? When you shift your graph upwards, which we will do eventually, did you guys do that last year? Shift up and down. When you do that, your amplitude won't necessarily be where your highest point is lying.
Okay.
But it will always be the absolute value of what? The coefficient. Okay. Or half the distance between your max and your min. Okay, questions before we move on? Okay. What is the amplitude for the following questions? And I'm just going to write them down. Number 1, y equals 7 sine of x. Don't blurt it out, just write it down on your paper. Number 2, y equals negative 3/4 sine of x. Number 3, y equals a sine of x. All right, you're just writing down the answers. 1, 2, 3. All right, what's the answer for number 1? No work needed. Do we agree it's 7?
Yes.
What's the answer for number 2? Positive 3/4? Positive. Why? Because it's always positive and we take the absolute value. Okay, number 3? Yes or no? What is it? Absolute value. If you forget the absolute value, it is wrong. Be careful. Why is that? Because a is a variable, which means it could be negative. Is there a chance a could be negative? Yeah, I didn't say a is always positive. If a could be negative, let's say it was negative 3, and you just put a, that means your amplitude is negative 3. Is that correct? No. So you have to put the absolute value around your variables. So if this were to come up on a test question, and you put 7 3/4 and a, would I mark it wrong? Yes. What do you need around your variable? Absolute value, because it's a variable and there's a chance it might be negative. Questions? All right. We're going to just try to graph 2 really quick without making the T-chart. And you guys did not make T-charts all the time last year, correct? Okay. So that's what we're going to do. We're just going to get some more practice then, since you've done this before. Number 1, y equals 3 sine of x. What's our amplitude here? Oh. Amplitude is 3. I'm going to extend, and we're only going to graph it for 1 period. So 1 period is always between 0 to 2 pi for today's lesson. 0 to 2 pi. And what did I say? You take the 2 pi and cut it in half. And what's half of 2 pi? Pi. You take the pi and you cut that in half. And what's half of pi? pi over 2, and then I go right in here. And we should know what that is, but you can always do a double checker with your counter. 1 over 2, 2 over 2, this would be 3 pi over 2, and 4 pi over 2 is 2. All right. Now, what you do have to do is you do have to label your amplitude. Say your amplitude is 10. You don't have to give me all the little tick marks. If you just come up here and put 3 and -3 or 10 and -10, am I okay with that? Yes, 3 is not too big. I am going to put the ones in between. Okay. Now, because it's positive, it's the regular sign graph. It's not flipped around. So I always think of it as a snake shape. Do you see the snaky graph? Or an S shape. Snake starts with S. Sign starts with S. It looks like an S, however you want to think of it. Do you see the snake or the S? Yes? All right, so I always think of 0, max, 0, min, 0. Okay, sign graphs have 1 max and 1 min. So 0, max, 0, min, 0. You can remember that, then you're good. So sign always starts at your 0. The next point is my maximum, but it's not 1. For this graph, it is what? 3. Back to 0. Minimum, which is -3, back to 0. 3 zeros, a maximum and a minimum. And then you make it as curvy as you can without any V shapes. And there you go. Makes sense? Okay. Did I go too fast on that one, or are you guys okay? Okay. Y equals -4 sine x. What's the amplitude? 4, because the absolute value of -4 is 4. Does the negative have any impact on my graph? Is it going to change anything? Yes, the amplitude, it doesn't make it negative, but what does the negative do? Flips it. So instead of going 0 max, 0 min, I'm going to go 0 min, 0 max, 0. So it just, these two switch places. All right. 1, 2, 3, 4. 1, 2, 3. -4, and you do have to have those points labeled, whatever your max and min are. Okay, so 2 pi. What's 2 pi cut in half? Pi. What's pi cut in half? Pi over 2. And 1 over 2, 2 over 2. This would be 3 pi over 2. You do want to look for those patterns, because when we're doing some shifting and periods are changing, you do want to find that pattern. 1 over 0, 1 over 2, 2 over 2, 3 over 2, 4 over 2. All right, still starts at 0. The sign always starts at 0, and then it goes max or min if it's negative. Min, so go down to -4, back to 0, just like that middle one there. Maximum, which is 4, back to 0. So make your curvy shapes. Got the hang of it? Easy enough?